In the time it takes to watch this presentation, 18 structural fires will have started somewhere in the United States. That's close to 500,000 fires a year. The cost? More than $10 billion annually, and countless lives put at risk. As cities become denser, building with fire safety in mind has never been more critical, and the options available for offering protection have never been greater.
I think it's a very exciting time in our industry because there are advances in products such as fire-rated glass, allowing us to achieve building and design systems that we haven't been able to do in the past. We're working closer with specific industries and manufacturers early in the design process, hoping to make the full build-out process more efficient.
Architectural glass, in particular, has seen tremendous advancements in the past 20 years, raising the bar for fire safety and performance. Yet, many architects and specifiers don't consider themselves experts on the finer points of fire codes and code-driven products. Staying fully versed on product compliance can be daunting, particularly when it comes to something as specialized as fire-rated glazing.
That's always a challenge, is trying to determine what code we have to work with in designing a building at that location.
We often hire code consultants to assist us, but navigating the codes and working with the Department of Buildings, it's always a challenge, especially when you're dealing with safety conditions and fire-rated glass and egress stair conditions.
Fire-rated glazing may be complex, but its purpose is simple: protection. And it serves a vital role in an overall strategy for safeguarding people and property. Developing a comprehensive fire safety plan for a building needs to include multiple systems that fall into the categories of passive and active forms of protection.
A passive fire protection system would be something that's built into the building, more of a construction type, which would be more related towards fire doors, fire walls. It's more of a construction component of the protection. It could be a rated ceiling, rated walls, rated doors, rated windows. An active fire protection would be more like a fire alarm system where you have smoke detectors, heat detectors, or if you have a sprinkler system. Those are components that require some type of activation to either notify the occupants to get out of the building or something to help control the fire from getting out of control or actually extinguishing it itself.
You can have built-in barriers that prevent or slow the spread of fire from one part of the building to another. This is a passive system called compartmentation.
An easy example of that would be an electrical room. An electrical room is a one compartment in almost any building that you would have, and in that room it's designed to make sure any fire incident was to happen in that room, it's designed to make sure that whatever happens would maintain and stay in that room. If you can keep a fire contained to a certain area, it's like taking a glass cup and putting it over a candle. If you take a glass cup and put it over a candle, it'll run out of oxygen and the fire will actually smother, so it keeps that fire from growing even more significant.
But how do these barriers affect the building's aesthetic and functional design?
When you have to create barriers in a building, it does sometimes have a negative impact because you're having to close off, segregate certain areas of the building. So it does sometimes negatively impact the design because you have to put walls up where you don't necessarily want walls. You want to bring light in, you want to have air circulation, you want to have eye contact with different spaces. So using glass in those areas does help to eliminate those negative impacts.
Is compartmentation even necessary if you have good warning and suppression systems in place?
There are many examples of where there has been a bad design for a fire alarm system or other types of features where the components haven't functioned properly, as well as the maintenance of the system. There's also been a couple of examples with sprinkler systems where they've been shut off too early by either responding crews, or there's been some kind of malicious behavior with those that have shut those off that have caused those not to function as properly either.
Anyone who has ever forgotten to replace a battery in a smoke detector understands that active systems are not infallible. Alarms and sprinklers are invaluable allies in the fight against fire, but they are vulnerable to outside influences that could interfere with their activation. Fire-rated construction materials provide the reassurance that there is a reliable line of defense should other systems fail. Now, certain types of specialized glass can fill this role.
Well, first off, if we compare fire-rated products in general to non-rated glass, I would clearly expect the non-rated glass to fail before the fire-rated product. The fire-rated product is going to be exposed to some very high temperatures, depending upon the duration of the rating, maybe in excess of 1,000 degrees Fahrenheit. Part of the test would be that that glass stay in place during that exposure. When you test a fire-rated glass product, first off, there are two types of tests that would be performed depending upon whether I'm trying to achieve a fire protection rating or a fire resistance rating. When the glass is used in a door or as a vision panel on a wall, it is typically has a fire protection rating and it is tested to 1 standard. For a fire protection rating, we expose the glass to a standard temperature time curve, and the basic criteria is that the glass remains in place for the duration of the test.
In the U.S., for any fire rating over 20 minutes, glass is also required to pass a hose stream test. Canada requires this test for all fire ratings.
When we take the glass out of the furnace, we will then spray a hose stream on that glass that basically evaluates from an impact standpoint as well as a thermal shock standpoint the integrity that remains in that assembly.
Occasionally, some manufacturers have challenged the need for the hose stream test, attempting to have it eliminated so products that don't pass it can be allowed. But you should not use products listed for 45 or 60 minutes that have not passed the required fire hose stream portion of national test standards. If you do, you may be accepting unneeded risks and liability. For glass that can't tolerate thermal shock, some people have attempted to create combination systems. They have installed early activation sprinklers close to the glass to bathe it entirely during a fire, sometimes referred to as a deluge sprinkler. This theoretically prevents the glass from ever getting too hot. But the 2012 version of the IBC has eliminated such options as unacceptable, requiring fire resistance ratings to be earned without supplemental protection.
Historically, the only fire-rated product that was available in the U.S. was wired glass. So as the requirements were developed for safety glazing, it was recognized that we had to have an allowance for fire-rated products. So at the time, there was a lower test standard that was recognized by the codes. It's part of the ANSI test standard, but the impact was much less than what I would use for Category 1 or Category 2 glazing. So the codes allowed in fire-rated applications the use of a product tested to a lower safety glazing criteria, recognizing that we had to meet a fire performance as well as still have some impact resistance. It just wasn't the same as safety glazing was.
The other reason why they used wire glass was because of the wires inside of the glass. It gives a sense of security and lets people know that, hey, there's some strong glass here. Unfortunately, that's not exactly true. The glass is more brittle, and when it does break, the wires hold it together slightly, but it creates more of a hazard to the individual. If it's in a door and your arm goes through it, the glass holds together and the shards are definitely damaging to individuals.
Beginning in the 1980s, advancements in manufacturing resulted in new materials that looked like ordinary glass and didn't require wires to pass the testing. Today, there are multiple products that outperform traditional wired glass in both fire and impact safety.
As we've developed other products, tempered glass products, ceramic glass products that can achieve a fire rating as well as achieve the higher human impact rating, the codes have been modified to say that where I have to have safety glazing, I need to meet that higher requirement for safety glazing. So the exemption that was in the code that allowed normal 1/4-inch wire glass to be used in areas subject to human impact was taken away from the code, or taken out of the code. That's not to say that wire glass can't be used. but wire glass in the form that it traditionally has been used would not typically meet the safety glazing requirements.
While each fire-rated glass option has unique characteristics, all the new products can be divided into 3 primary categories: specially tempered glass, glass ceramics, and transparent wall systems.
There's a variety of fire-rated products available through different manufacturers, and it really depends on what performance you are looking to get out of your glass. Some of them perform really well as far as the fire rating goes. They do not perform as well for the safety impact rating or the hose stream test. And all of these things are things that need to be considered when choosing that product, and make sure that you're getting the one that is going to fit your needs the best, because they are not all created equal.
So the reason the codes have different ratings is the level of protection that is anticipated for that particular application. So for example, in a corridor, the basic concept is that I want to keep the fire, the effects of the fire, from impacting those that are going to be walking down the corridor as they egress the building. So it's generally anticipated that that will be fairly short time period after the fire has started. So a lot of times our ratings are a little bit less for a corridor wall than it might be for another application.
A closer look at the new materials on the market quickly highlights the need to pay attention to their differences. For example, specially tempered glass is a category of materials that has been able to earn only the lowest level of fire rating given by the testing labs, 20 minutes. But since it does not pass the hose stream test, its applications are limited. Plus, it does not meet Canadian requirements even for 20-minute ratings. Fortunately, this is not the only new option. A second category of fire-rated glazing isn't technically glass at all. It's ceramic. New manufacturing processes have made it possible to produce exceptionally clear ceramic that looks and functions like ordinary glass, while retaining ceramic's superior tolerance for heat. The latest advancements have made it possible to all but eliminate visible color, providing excellent clarity.
One of the advantages to a ceramic product, as I understand it, is that it does not expand when it's exposed to different temperatures. So in a fire scenario, as the temperature increases, the glass is not going to expand.
When they first came out, there was a little bit of waviness and a little darkness to it, but now they've worked on it and it looks just like regular glass.
Nowhere has this advancement in product technology made a greater difference than in designing educational facilities.
Well, as an architect who works in schools, I believe I'm designing probably one of the most important structures that our society does today, which is a place for our children to learn. And so life safety is extremely important, and we have to be diligent with the materials that we choose. Not only are we protecting the children and the staff that work in the school, but there's also a great deal of investment in equipment and materials and the buildings themselves. And so we want to make sure that we limit the spread of fire, we limit the spread of damage, and that people can get out safely, and those who are coming to fight the fire are there who will be also protected. If the fire sprinklers go off and the glass is heated, regular glass will shatter and there'll be a breach in the fire protection, whereas the ceramic glass will hold up.
Not only can modern fire-rated glazing be designed to protect against the spread of flames and smoke, but in some applications, it must also be able to provide resistance to impact.
So when I test glass for safety glazing purposes, which is that human impact consideration, we have a Category 1 and a Category 2 product. And we distinguish those by the weight of the lead bag that is swung to impact that glass and what happens to the glass when it's impacted by that lead bag. So the Category 2 product, in the annex of the test, it tells me that that is to represent the impact that might occur should an adult impact that glass, whereas the Category 1 impact is more representative of a small child running into or impacting that glass.
Through advanced laminating techniques or the application of surface-applied fire-rated film, fire-rated glass ceramic can now meet high-impact safety standards as well as fire codes, satisfying the Consumer Product Safety Commission's highest requirements. In addition to specially tempered glass and glass ceramics, There is a third category of fire-rated products: transparent walls. Such materials cross a line from being known as fire protective products to being fire resistive.
If a glass assembly has a fire protection rating, it basically means that the glass will remain in place when it's exposed to that increase in temperature for the temperature and the duration that it has been tested. If a glass has a fire resistance rating, in addition to staying in place, we evaluate that glass for the transmission of heat. We will actually measure the temperature of that glass on the unexposed surface.
Heat becomes an issue in areas where occupants could potentially be trapped for a long period of time, such as stairwells, exit corridors, or where sensitive equipment would be damaged by heat even if no flames reached it. Although transparent wall panels look like window glass, they are tested to wall standards and can be installed in floor-to-ceiling sizes.
So the transparent wall panels, they're made up of different layers of fire glazing and of intumescent inner layer. In the event of a fire, the intumescent layer turns into a foam, and the entire product prevents the transfer of heat from the fire area to the area that you want to be safe.
This revolutionary thinking in glass has opened up entirely new vistas in design.
A lot of times, architects are dealing with, the three-dimensional box, but there are times when we want to explore past that box, or to view past it, or to have connections with other spaces.
It isn't only glazing that has been undergoing such radical transformation. Fire-rated framing systems have been keeping pace with the rapid changes, offering a broad range of new options.
The structure and the design of fire frames today has improved progressively. I think that we're always looking for slimmer lines, and although the priority has been on the clarity of the glass and the fire safety of the glass, the frames have progressively gotten slimmer over the years, which is definitely a benefit.
Sleek steel framing with narrow sight lines offers a less intrusive profile than fire-rated framing of the past. Architects can now find fire-rated aluminum framing, hardwood frames, and even fire-rated glass floor systems. These frames have all undergone the same fire and hose stream testing that glass is subjected to. There are also frames that are tested as a barrier to heat, making them compatible with fire-resistive glass used in transparent walls. A new technology, fire-rated curtain wall framing with the appearance of structural silicone glazing, allows for multi-story expanses of glass. Now design professionals can create large fire-rated glazed walls with a smooth monolithic appearance. The various framing materials can be custom finished to complement the non-fire-rated frames in a building, giving architects a wide range of freedom to meet fire codes in creative ways. With so many diverse products in the market all claiming to offer some level of fire safety, how can you ensure that the right material is specified and installed?
By referring to a document called the International Building Code. The International Building Code is developed by the International Code Council, which is a private entity that develops a family of codes that addresses building, fire, plumbing, mechanical, and so forth.
The code is our big cheat sheet. Really, you use that as your Bible, depending on what district you're in, what city, what state. You have to reference the specific code that is applicable, and of course, understand all of the updates and new versions which come about all the time.
Under the 2012 International Building Code, labels for fire-rated glass have also changed. Markings indicate fire and impact ratings, as well as if the glass is tested as a wall, if it meets the hose stream test, if it passes temperature rise tests, and if it meets the standards for a door assembly.
When I look at the new labeling system, you will see either a W, a D, or an O. And basically they represent the test standard that was used to evaluate the product. And in some instances, the product may have been tested to multiple test standards, and I may see multiple letters in the label. But if I see a W, the product's been tested for a fire resistance rating, with W standing for wall. So it is essentially the same as a fire resistance rated wall. If I see D, The D stands for door. That means that glass product has been tested as a glass light within a fire protection rated door. And if I see an O, it has been tested as a fire window assembly that may be used in a wall, O standing for opening.
A lot of times the general contractor or the building owner will try and push us to use a product that has a lesser rating because they say that they have special permission from the building inspector or from the fire marshal. This is something that should really draw your attention and cause concern for the glazing contractor because we are liable. The person that puts the glass in is liable for installing the proper glass.
A lot of times people will unintentionally put down, we want XYZ brand or equal. And the problem with that is who determines what is an equal. A lot of times the contractor will, and he'll submit a substitution request or he'll just substitute it on site of one product over the other. Really what should happen is the architect is the authority on what products are quote equivalent, and he or she should be the one that determines which products are acceptable.
All fire-rated glass products are not the same, and a lot of the differences have to do with quality and craftsmanship and ultimate design of the wall, color of the glass, consistency of the glass, and the glass makeup. Depending on the manufacturer, depending on the make of the glass, all vary. The frame design, the slimness of the frames, that varies. It's critically important to understand what's out there in the industry today and what the options are and see existing case studies or examples of fiberglass in the field today.
Another factor shaping every aspect of today's design is the push for sustainability. Of particular interest is the practice of daylighting, incorporating more natural light in a building and reducing dependence on artificial lighting. Even in this area, fire-rated glazing is making a difference.
You now are, looking at using glass in place of a solid wall, which allows more light into the space, brings down your energy costs, allows you to not have the lights on all the time. So some fundamental aspects of daylighting and energy savings. The more light you get into the building, the more natural daylight you get into the building, always the better. And again, it allows you to see different spaces, to see where you're going, to see where the entry to the stair is, and not have to look at a map to know where the egress stair is.
Glass is one of the few materials that can be continuously recycled, and manufacturers are taking full advantage of new ways to lessen the impact on the environment. Depending on the fire-rated glazing and framing products chosen, the materials can contribute to LEED requirements, ranging from recycled content to daylighting, optimized energy performance, and low-emitting products for paints and coatings.
It's a very exciting time right now. I love seeing the progression of the industry and products, and there's always something new. I'm always learning something new. And every single project, there's something, that we have to research and learn more about. The industry is evolving, and the standards are getting higher, and codes are getting stricter, and we have to evolve and, create more products that are going to ultimately get us what we want.
As the world becomes more urban, safety concerns will continue to grow and evolve. Today's fire-rated glazing is up for the challenge, providing greater performance, larger sizes, and more design options than ever.